All right, good morning. So today we're going to start proving triangles are similar. And we have proved that triangles are congruent before. So I don't know if you remember all the ways that we could prove triangles congruent. Remember, we could never prove triangles congruent by AAA or
SSA.
Or SSA or ASS. Yeah, can't, not the bad word and not AAA. But today we're going to prove that triangles are similar. So remember, you can prove triangles congruent. That means the exact same size and shape by side, 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 angle, angle, side, or HL. Never, ever prove triangles congruent by AAA or ASS. That's a bad word. So today we're going to learn how to prove triangles are similar. So remember, similar is the same shape, but not necessarily the same size. So one could be smaller, one could be bigger. So there's going to be three ways that we can prove that triangles are similar. One of them is just called angle-angle similarity. If you know that two angles in one triangle equal two angles of another, the third angles are automatically congruent, but we don't say AAA. As long as you have at least two angles, we can say the triangles are similar by AA similarity. So it's AA similarity. So that's one way. So remember, they can't be congruent by AAA. They can be similar. Okay. Another way is side, side, side. Now, the sides will not be equal to each other. They'll be proportional. So, like, this is 4 and this is 2. This is 6, 3, 8, 4. That makes it easy. So these two sides correspond. So if I do 2 over 4, what's that reduced to? 1/2. If I do 4 over 8, what's that reduced to? 1/2. 3 over 6 reduces to. So as long as they are proportional, they are similar by side, side, side similarity. So for congruent, all the sides would have to be equal, proportional for similarity. Then the last one we have is side angle side similarity. So let's see if I can think of something. I keep doing the 1/2 thing. Oh well, it's fine. In my mind, I keep doing 1/2. 2 and 4. So side angle side, the sides would be proportional again. So 3 over 6 would reduce to 1/2. 2 over 4 would reduce to 1/2. Does that make sense? So we only have three ways: angle angle, side angle side, and side 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 similarity. The sides would be proportional. So you're going to have some problems where you have to determine why the triangles are similar. Now, anytime you see arrows, that means those lines are parallel, and you're always going to have angles that you can mark. So arrows start with the letter A, angles start with the letter A. In my mind, anytime I see arrows, I know it's going to be angle similarity, because you could mark your vertical angles here, but since those lines are parallel, you could also mark your alternate interior angles. So those triangles would be similar by angle similarity. Anytime you see arrows, why are they going to be similar? Angle. Okay? Arrows start with A, angles start with A, angle. Okay, let's look at this one. So I know I have my vertical angles. I need to see if these triangles are similar, because I've got some sides marked. Are they similar by side angle side? So I've got to check my sides and make sure they're proportional. So like 4 corresponds with 12. What does 4 over 12 reduce to?
1/3.
1/3. Okay, 2 corresponds with 6. What's 2 over 6 reduced to?
1/3.
So since it's the same, I could say the triangles are similar by side angle side similarity. You guys okay so far? Arrows mean AA. Check to make sure the sides are proportional. Now these two triangles are congruent, but since they're congruent, they're also similar. Why would they be congruent and or similar? Side, 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 yeah. So all three sides are marked. So it's okay if they're congruent. They're also similar because they're congruent. Okay, let's look at this one. When you have triangles connected, you have one inside the other, my thing to you would be to redraw the triangles separated from each other. So I've got this smaller triangle, which has 9 and 10. And then I've got this bigger triangle. What would this entire side be?
12.
What would this entire side be?
15.
15. Now notice they both have angle A in common. So I'm going to see if I could prove these triangles similar by side, angle, side, but I have to make sure that the sides are proportional. So 9 would correspond with 12. What does that reduce to? 3/4. 10 corresponds with 15. What's that reduced to?
2/3.
2/3. Are those the same?
No.
Those are not similar. So you have to check and make sure the sides reduce to the same thing. If you have a triangle inside another, redraw them separated from each other. Okay, let's look at this one. So let's match our corresponding parts. So 2 would correspond with,
4,
so what's that reduced to?
1/2.
3 corresponds with 6, 1/2. 4 corresponds with 8, 1/2. So since they're all the same and there are 3 sides, why would those be similar? Side, side, side. Okay. What do all the angles in a triangle add up to?
180.
180. So I know on this one I have 42 and 58. This one I have 42 and 80. If I do 180 minus 42 and 58, guess what I'm going to get? 80. And this would be 58. So since all 3 angles are equal, we don't say AAA similarity. What do we say? Just AA similarity, yeah.
You could.
So your first few problems, you're going to decide, do you like my pie, Piper? Instead of
Like continuation.
So the first few problems, you're just going to say, why are the triangles similar? So like on this one, do you guys see how 2 angles are marked?
Angle.
Angle similarity, just AA. So like on this one, we would want to make sure that the corresponding sides reduce to the same thing. So 1 and 2, well that doesn't reduce, we just leave it. 2 and 4, does that reduce to 1/2?
Yeah.
So we've got a side, an angle, and a side, so why would they be similar? SAS, good.
Wait, what?
SAS, SAS.
Oh.
Yeah.
Number 3 is the
Side
same.
angles.
There's
Now number 3 is the
wait,
same
it's
problem, but I want to
different.
know the similarity ratio. What would the ratio be? What did they both reduce to? 1/2, so 1 to 2. What do you think if it's all 3 angles? Okay, good. Okay, so main thing, make sure you check your sides that make sure that they reduce to the same thing. If they don't, they are not similar. Let's see. Oh, and you cannot prove triangles similar by ASS. That is also a bad word. So notice this would be angle, side, side. So for number 8, the triangles are not similar. Okay. We need to move on. But those aren't too bad, are they? I see another bad word. Do you? Yeah. Okay. Okay. Since you had your assignment unlocked, I thought I'd just go ahead and look at a few because you guys were probably wondering what to do. Okay, so how many problems do you decide why? Let's see. All the way to number, goodness. Okay, all the way to number 20. So 1 through 20, you're deciding why they are similar. Number 21, we'll have some problems where we set up proportions and cross multiply and solve. So you will have some problems where you have to set up your corresponding parts just like we did yesterday and cross multiply and solve. So if I look at this example right here, and I want to find x, what does x correspond with on the other triangle? 5. So I would do x over 5 equals, and since I went from this triangle, the triangle on the right, to the triangle on the left, I have to go from the triangle on the right again, 4.5 over 3. And then you cross multiply and solve. So 3 times x is 3x. I don't know what 4.5 times 5 is. What is it?
0.5.
What?
22.5.
Huh?
22.5. It was his answer.
Oh, that's the final answer? Oh.
No.
His answer.
Divide by 3? What is it?
7.5.
7.5. Okay. Thanks.
Check the link.
When you have a triangle inside another, this part is so important. I want you to redraw the triangles separated from each other. So I've got that little triangle, which has 90 and 110. And then I have the bigger triangle. Is this one of your problems on your assignment?
Oh no.
You might want to look. If it's not on today's, I know it's on a different one. This is X. What is this entire side if it's 90 and 90?
180.
180. So once the triangles are separate from each other, then you can match up your corresponding parts. So X corresponds with
110.
110. 180 corresponds with,
90.
and notice I went right to left, so I have to go right to left again.
45.
Cross multiply. This I could reduce. Doesn't 90? I'm going to reduce that.
2.
Yeah. 2 over 1. That makes the math a lot easier. So 1 times X is X. 2 times 110 is 220. This one I know is on your assignment. Find this one. What number is this one? Number what?
25.
25? Okay, because this one's kind of tricky. Okay, so I've got to redraw my triangles separate from each other. So I have that top triangle, 4 and 3. And then I have this bigger triangle. I know that the bottom is 8, but what's this entire side? Is it 4x?
No.
Yes, x plus 4. Because if this was 2, the whole side would be 6, because 4 plus 2 is 6. So it's x plus 4 or 4 plus x, however you want to write it. Now let's set up our proportion. So how would you set it up? X plus 4 over 4, and then x plus 4 over 4, and then what?
8 over 3.
8 over 3. Now when you cross multiply, you have to do distributive property there. So 3 times x is 3x. What's 3 times 4? Plus 12. And then 4 times 8?
32.
32. Minus the 12 on both sides. 3x equals 20. What would x be? I know it's a decimal.
20 divided by 3. 6.666666.
Let's say 6.7. Let's round it to the nearest tenth. 6.7.
And then we put that on our assignment.
So yes, put 6.7 on your assignment.
Round to the
Okay, let's try to match corresponding parts. What does x correspond with on the other triangle? Can you tell? 12. X over 12. And then 42 over 14. And then cross multiply. Let's look at this one. Let me set up one more because this is a triangle inside of a triangle. So I've got this top triangle. Is this one on your assignment? No. So top triangle is 6 and 9. And then the bigger triangle, the bottom is x. What's this entire side? 8. So if you have a triangle inside of another, you have to redraw it. Okay. So I could do x corresponds with 9. X corresponds with 9, and then 8 would correspond with 6. And then cross multiply.
So this is number 26.
Is this on your assignment?
We'll do
No,
that.
okay.
X over 12 equals 42 plus 42.
Oh, is this one's on your assignment?
Yeah.
Oh, okay. So did you guys solve it?
No.
I'm trying to right now.
Okay, so 14 times x is 14x. And I don't know what 12 times 42 is, so you guys are on your own.
104.
You're on your own. You can do it. You can do it. I have faith.
36.
So first
36.
times 32.
Okay, so I know. Here, let me look at your assignment real quick. There are a couple word problems. So let me look at these. So on the word problems, I like to draw little pictures. So it says, in sunlight, a cactus. I just found a picture because I can't draw a cactus. A cactus casts a 9-foot shadow. So I've got this cactus and it casts a 9-foot shadow. At the same time, a 6-foot tall person, 6 foot tall, casts a 4-foot shadow. How tall is the cactus? So when I see problems like that, I guess I kind of always make like 2 L's. So I know I've got a 6-foot tall person that casts a 4-foot shadow. I don't know the height of the cactus, and it casts a 9-foot shadow. So how could you set up that proportion? 6 over x equals, yeah, and then you cross multiply. Did you know you could do 6 over 4, height over shadow equals height over shadow again, and you are still multiplying the 4 and the x and the 6 and the 9. So either way. I think I've got one more like that. So it says, Jake, hey, Jake. Jake wants to measure the height of the Sears Tower in Chicago. He uses a 12-foot light pole. 12-foot light pole. Measures the shadow at 1 p.m. and it's 2 feet. Then he measures the length of the Sears Tower shadow at 242 feet. How tall is the Sears Tower? So how could I set up that proportion? 12 over x to 242. And if you wanted to reduce that, you could. But you cross multiply. I'm curious, though, to know if this is accurate. Like if the Sears Tower is really as tall as... Yeah, we'll have to. Let's solve it. 2 times x is 2x. I don't know what 12 times 242 is.
2,200.
Divide by 2. What's x?
14,000 or 1,452.
That's right here.
So that would be in feet. We got to see if the Sears Tower is really that tall.
It is.
It is. Is that right?
Like this.
Okay, that's pretty good. Okay. So this isn't real. Oh, just a quick review. You can prove triangles similar by AA, side, 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 and side angle, side similarity. 3 ways. And then I just thought this was cute, although there's not snow. Now it's feeling like spring outside. That makes me happy. Okay, so there are a couple, there is a review problem from number 30. It's a review from like that first section. Do you guys remember how to do problems like number 30?
Yeah.
You do remember?
Yeah.
You put the x next to each of those numbers. So 5x plus 6x plus 9x equals, and then the perimeter is 220. You'll solve for x. When you get x, you have to do 5 times whatever x is, 6 times whatever x is, and 9 times whatever x is to get those lengths. Okay?